In part 11 we're going to look at integration again, but we're going to connect it to the area under a graph. A definite integral, an integral that has numbers, here a and b, can be written in this form. So when we integrate f dash x, we then write it, if it's a definite integral, in squared brackets, putting the numbers on the right hand side of the second bracket, and then we evaluate this function first at b and then at a, and we take one away from the other. It doesn't matter about the constant of integration, because even if we put in when we evaluate at the 2 points, it will cancel out. A definite integral can be thought of as the area under a graph. So if I have a function f of x which goes from a to b, then the integral of f of x is this area under the graph. If the area happens to be underneath the x-axis, then that integral will have a negative number. Let's look at an example. We need to evaluate this expression between 1 and 3. We can't integrate it as it is. We need to multiply it out first. Now we can integrate it term by term. So using squared brackets, we can integrate x squared, then we can integrate 8x, and then we can integrate 15. Remember to put the numbers on 1 and 3. We're now going to evaluate all of that expression at the value 3 and then at the value 1, and we're going to take them away from each other. So we then simplify and we get the answer 6 2/3. Here is a typical exam question for you to try. Press pause, and once you'd finished doing it, press play again to see the answers. Okay, part A. We just need to integrate. So again, we can integrate term by term. X cubed integrate, 6x squared, and 9x. Remember, this is an indefinite integral, meaning it's got no numbers on it, so we need to put plus c. In part B, they're asking us to integrate the same function, but they've now given us limits. They've given us 0 to 2. So we know what the function integrates to, but we now put it into squared brackets, and we don't write the plus c. We put the numbers on the right hand side, and we evaluate the function first at 2 and then at 0. We actually work these values out, 6. So the area under this graph between 0 and 2 would be 6. Part C. We need to find this shaded area. It's the area under the graph, but not part of the triangle. So the shaded area is the area under the graph minus the area of the triangle OAB. So to find the area under the graph, we integrate between 0 to 2, and the area of the triangle is a half times 2 times 2. We know the integral is 6 and the area of the triangle is 2, so the shaded area is 4. We'll leave you with the key points from this section.